On a simple table, a loaf of freshly baked bread and a strip of aspirin tablets may seem to have nothing in common, and yet curiosity about gluten began in an unexpected place, a Mexican restaurant in New Zealand. I am Argentinian. I come from one of the greatest wheat-producing nations in the world, where bread is culture, heritage, and tradition. In my country, until the early 2000s, I had never heard anyone complain about gluten. Here, however, the Kiwis were very particular about it. Every time I served a plate, the question was the same: does it have gluten? And that was curious, because in a Mexican restaurant, the staple is not wheat but corn. Intrigued, I began to investigate. I discovered that gluten, though harmless to many, can cause serious problems, and that there is no definitive cure. Today we know that the gluten content in wheat has increased over time. The last major crossbreeding took place in the early 1970s, though there were others before and after. To truly understand the origin of this story, we must travel thousands of years back to the Fertile Crescent. There, wild wheat was first domesticated. Farmers selected the largest and strongest ears. Without knowing, they were increasing the gluten, the protein that gives elasticity to dough, and made possible the creation of softer, airier bread. That improved wheat spread along trade routes and became the foundation of entire civilizations. But every advance has a price, and the same land that fed those harvests in time began to tire. Intensive cultivation, year after year on the same fields, wore the soil thin. Harvests became less abundant. Mankind realized it had to give back to the earth what it had taken. Thus began the search for fertilizers. First, plant remains, manure, compost, then more potent materials. They did not yet know the names or the chemical formulas, but they knew these gifts restored strength to the land. Unknowingly, the story of bread was brushing against another story, that of how humanity would learn, centuries later, that nitrogen, phosphorus, and potassium were essential for cultivation. At this point, wheat and gluten, born of agricultural achievement, led to a new need: to fertilize the land, to sustain production. And that search would take us to the other side of the world, to a resource that would change agriculture and spark international disputes. On the arid coasts of the South American Pacific, off present-day Peru, lie islands and rocks covered in a white layer that looks like snow but is guano, centuries of accumulated seabird droppings. The Incas, long before Europe knew of it, were already using it to fertilize their terraced fields. It was so valuable, its collection was regulated by strict laws and guarded by watchmen. Its secret lay in its composition: extremely high levels of nitrogen, phosphorus, and potassium. Though in those days no one knew these names, they only knew it brought life back to the earth. In the 19th century, Peruvian guano became the most coveted fertilizer in the world. Peru rose from a peripheral country to an agricultural power. At its height, guano exports represented 60% of the nation's income. In 1856, the United States passed the Guano Islands Act, allowing any citizen to claim for their country any uninhabited island with deposits of guano. But where there is wealth, there is conflict. England stirred tensions between Chile, Peru, and Bolivia. The War of the Pacific, fought between 1879 and 1884, was, in large part, a war over fertilizer. In the end, Chile won territories rich in guano and saltpeter, but much of the profit ended up in European hands. Even the richest reserves run out. And when guano began to grow scarce, humanity looked for answers in chemistry. At the end of the 19th century and the dawn of the 20th, German chemist Fritz Haber discovered how to fix nitrogen from the air and produce ammonia. Together with Haber-Bosch, he industrialized the process in 1913. The Haber-Bosch process replaced guano and revolutionized agriculture, making large-scale fertilization possible. But the same process that fed the world was also used to make explosives. During the First World War, Germany, blockaded by sea, continued producing gunpowder and munitions, thanks to synthetic nitrogen. Haber, of Jewish origin, was also a pioneer in chemical warfare. He introduced chlorine gas at Ypres in 1915 and helped develop mustard gas. In the midst of this time, his wife Clara took her own life, unable to bear the contradiction of his work. Decades later, chemical companies like IG Farben and Bayer, linked to these developments, took part in war crimes and human experiments during the Second World War, using gases derived from Haber's work in extermination chambers. Today, Bayer is one of the largest pharmaceutical companies in the world and maintains operations in Israel. A historical paradox, hard to ignore. And so from bread and guano, we arrive at a laboratory and a pill that, ironically, bears the mark of that same history. We return to the original table, bread and aspirin. Once it was a simple image, now it is heavy with the weight of history. Bread took us from the Fertile Crescent to wars over fertilizer, from Inca guano to industrial chemistry, and from there to weapons and Bayer. Aspirin's symbol of relief is also a reminder that many solutions come from paths stained by ambition and tragedy. In the end, the story of bread does not end in the bakery. It ends in a laboratory. And aspirin does more than soothe a headache. It soothes the conscience of a world that prefers to forget where its solutions truly come from.